So, what are statistics? Statistics are defined as the practice or science of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportions in a whole from those in a representative sample. So, this is one definition of what statistics are, and I might argue with this statement that it must be large quantities. It doesn't always have to be super large quantities. You can learn a lot about statistics even from a small sample. But this latter part that I bolded here is the most important. It says, for the purpose of inferring proportions in a whole from those in a representative sample. So this is really the power of statistics. And I started with this image here. This is in Baja, Mexico. And say you were interested in the difference in cacti height in the valley or the basin here versus on the ridge. Well, it might be hard to tell with the scale of this picture, but to go and measure every cacti in this huge area would take an enormous amount of time. It just would not be feasible to do that. So instead, you can sample the landscape. So you could use quadrats, which are one type of replicated sample, often in a square or rectangular shape, and they would all have the same size. And within there, you could sample the heights of different cacti down in the basin, and you could compare that to similar quadrats replicated or repeated along the ridge. And you could then infer from these samples about the whole population, as long as your samples are representative. So quadrats are very useful. They are spatially replicated units. You want to randomly choose them because if you just said, well, I'm going to put it right here on this big cactus, that would bias your sampling, right? So you want to randomly choose them. You also need to have replication so that you're not just choosing one area where there just happens to be tall cacti versus an area where there isn't. You want it to be replicated to have more chance of being representative of the whole. And you want to make sure that these are somewhat independent of each other. That is, you're not putting all the samples right next to each other and sampling just this one small area. You want them to be somewhat independent and spatially distributed. So once you have that, you've got an experimental design and you're ready to collect some data. So you go out and you do the hard work, you rope off or measure your quadrats, and then you measure the height of your cacti or whatever you're interested in, and you put it into a spreadsheet format in something like Google Sheets or Excel. And you're going to enter all of the data for the two different categories, or maybe you have even three groups that you're looking at. That's okay too. But you're going to record all this data, put it in a spreadsheet. And the cacti is just one example. There are other examples, such as this one, which we're going to talk about here, about comparing bird collisions on what is known as safe glass, shown on the right here, which has these sort of dots and maybe is a little more reflective, and it makes it so theoretically, birds would not fly into this as frequently as they would a more regular transparent glass, and that would reduce the number of collisions and fatalities of birds. But of course, this is a great idea, but it needs to be tested statistically. So we are going to delve into a data set looking at bird mortality at a sample of a city, because you couldn't do this in all locations. But so you would want to sample some buildings of these two different types, collect the data, and then put it in your spreadsheet and analyze it.